In this example, we're going to tell whether an equation represents an inverse proportion, and if so, we're going to identify the constant of proportionality. So again, when we did this with when we had direct proportions, we looked to isolate the y, and we wanted to get it in a form of y equals that constant times x. Or we could have had it as the constant equals y divided by x. Now that we're dealing with inverse, because we're dealing with inverse, we could still try and isolate the y. So if we get the y on one side by itself, if we have y by itself, we should end up with y equals the constant over x. So we should have a constant value over x. Or we could end up with a constant value equaling y times x. So if we get y times x on one side equals something, that also means that it's inverse. So in this equation here, we have 1/2 y equals 5 over x. We should notice that y is already on one side by itself. So y is by itself on one side. The only thing with it is a coefficient of 1/2. So to get rid of that half, I'm going to multiply both sides by its reciprocal, which is 2. When I do this here, 2 times a half becomes 1. So I'm left with 1y equals, and then this is 2 over 1, we'll say. 5 times 2 on top is 10 over x on bottom. X times 1 would be x. So we have y equals 10x. Now that I have y isolated, I'm going to look for the equation that shows y isolated. And y equals a constant over x is what we're looking for. In this case here, we have y equals 10 over x, which means that our constant is 10. So when we are using an equation to determine if it's inversely proportional, we want to either isolate the y, or if we end up with something, let's say we had an equation that was y times x equals 10, that also shows us that it is an inverse proportion because we have the setup of the two variables multiplied by each other giving us a number. So that would mean it's in inverse proportion as well.